It's a GATE 2006 question based on three-phase induction motors. So the question statement is like a three-phase 4-pole 400 volt 50 Hz star connected induction motor has the following circuit parameters. The stator winding resistance R1 is given as 1 ohm. Rotor resistance referred to stator side, that is R2 dash, is given as 0.5 ohm. The stator winding reactance X1 is 1.2 ohm, which is nothing but the rotor winding reactance X2 dash. Basically both are the same, and Xm is a magnetizing reactance which is given as 35 ohm. Now you will have to calculate the starting torque when the motor is started direct online, and you will have to use the approximate equivalent circuit model that is mentioned in the question. So basically you will have to find out the starting torque of the motor with the given circuit parameters, and you will have to use the approximate equivalent circuit model of three-phase induction motor. So we have already studied the equivalent circuit of three-phase induction motor. Please watch the video on this YouTube channel, which is based on equivalent derivation of equivalent circuit model of three-phase induction motor. So please do watch that video. That will help in understanding this equivalent circuit model of three-phase induction motor. Now for this question, for this given data, you will be calculating the starting torque, that is the question. So A, B, C, D are the four options. Out of these four options, only one statement, only one option is correct, that you have to choose that correct option after solving this numerical using this equivalent circuit model. So this is basically the approximate equivalent circuit model, and here in this approximate equivalent circuit, this is the approximate equivalent circuit. Why? Because we have shifted the shunt branch towards the supply side. V1 is the applied voltage, that is basically supply voltage. It is given as 400 volt. I1 is the stator winding current. R1 and J times of X1, they are the stator winding parameters. Similarly, R2 dash by S and JX2 dash, they are the rotor. They are basically rotor winding parameters, right? So here I2 dash is the rotor winding current, which is referred to the stator side. Similarly, R2 dash by S and JX2 dash, they are the rotor circuit winding parameters, which are basically referred to as stator side, right? That's why you will see the dash, X2 dash, R2 dash, I2 dash, right? So I have already discussed all these things in the equivalent circuit of three-phase induction motor. Please watch that video. So basically this is the equivalent circuit model of three-phase approximate equivalent circuit model of three-phase induction motor, and the shunt branch has been shifted towards the supply side. So if you see the equivalent circuit, complete equivalent circuit is this, right? So here the shunt branch is at the center, right? So basically when you combine the rotor equivalent circuit with the stator equivalent circuit, you will get this shunt branch at the center, right? So when you take approximation, you can shift this shunt branch at this supply side, right, with some approximations like the no load current is approximately equal to the magnetizing current Im, right? So Im is the current which is basically flowing in this branch, parallel branch, which is having the magnetizing reactance J times of Xm, right? So I naught is equal to Im. This is approximation, that means when IC square RC, that is basically core loss, this is basically very small, so you can neglect this, right? So now you can calculate the torque of the induction motor. So for the calculation of the torque, you will have to first calculate the air gap power, that is the rotor input power, that is PG, right? PG is that we have derived, it is equal to I2 dash square into rotor circuit resistance, that is R2 by S, right? So once you know this air gap power, you can calculate the torque, right? So torque is nothing but the power per unit angular speed in air gap, right? So here the air gap torque you will have to calculate, right? So for that you will have to first calculate the air gap power PG, that is basically rotor input, right? So when you calculate this air gap power, from this air gap power you can calculate the three phase, you can calculate the torque, right? That is PG by omega S, right? So for three phase motor you multiply it by 3, right? So 3 times of PG by omega S. This is the expression of the torque. So let me call equation number 1. So your first job is to calculate this current I2 dash, right, with the given parameters. So how to calculate this I2 dash? So it's just have a look at it. Here I2 dash is the current which is flowing in this circuit, right? So I2 dash, you can write I2 dash, that is equal to this applied voltage V1, right? Applied voltage V1 whole divided by total impedance of this whole circuit, that is R1 plus R2 dash by S, right? This is the resistive part and the reactive part is J times of X1 plus X2 dash, right? So from here you can calculate the rotor winding current I2 dash. So V1 is applied voltage, that is 400 volt, right? So these winding parameter, they are given on single phase basis, right? Until unless stated, you will have to assume that these ohmic values are basically for one phase, right? So first of all, calculate the current per phase. For that we will have to take the applied voltage per phase and all the ohmic values that are basically per phase. So that will give you the current, per phase value of the current. So per phase voltage for a star connection, see this is a star connected motor, right? For a star connection, the per phase voltage will be equal to line voltage by root 3. So line voltage is 400 volt. So write here 400 volt and here divide by root 3, right? Divided by root 3, that is basically phase voltage. Alright, this is basically phase voltage. 400 by root 3 is a phase voltage, and here put all the winding parameters. R1 is 1 ohm, R2 is R2 dash by S, R2 dash is 0.5. Now you see that he is asking that you will have to calculate the starting torque. Starting at the time of starting, you know that the slip is 1 unity. So write slip S is equal to 1 plus J times of X1 is basically 1.2 ohm plus X2 dash is given as again same 1.2 ohm. Alright. Now you will have to use the calculator in complex board and you will have to find out this current I2 dash. So I have calculated this value that comes out to be equal to 81.59 with some angle that is minus 57.99. Alright, that's the value of this current, right? This is ampere, this is per phase current, alright? So that we have calculated the expression of the current, that is 81.59 with some angle that is 57.99, right? So this is, we are basically dealing with AC quantities, right? So AC means magnitude with some angle, right? So basically this is the lagging current that is basically represented by this negative sign, right? You know that applied voltage, we have angle of applied voltage is 0, right? Because we have taken applied voltage as a reference, so angle of this applied voltage is basically 0. So with this applied voltage, this current is lagging by 57.99 degrees, which is represented by this negative sign, that is basically lagging current, right? So now you have calculated I2 dash, put this value of I2 dash into this air gap power expression, that is I2 dash square R2 dash by S. So from here you can calculate air gap power PG, that is equal to, so we will take magnitude, so 81.59, that is square, and R2 dash is given as 0.5 ohm, alright, and here it is given as slip is basically unity, right? Because we have to calculate the torque, at starting, that means at slip is equal to 1. So here this comes up to be equal to, air gap power comes up to be equal to basically 33, 28, 3328.46 watts. So this is per phase air gap power. This is the air gap power for single phase. Alright. Now for three phase torque, you can calculate using this equation number 1, that is 3 times of Pg by omega s. So 3 times of air gap power Pg, that is 33.46, right, divided by ns, omega s. Omega s is nothing but 2 pi ns by 60, right? So 2 pi by 60, 2 pi by 60, and here this 2 pi by 60 into ns, right? Ns is nothing but 120 f by p. So 120 into frequency 50 hertz divided by number of poles. Number of poles are 4. There are 4 poles in the motor, right? So again use your calculator and calculate this torque, that is comes out to be equal to 63.6 Newton. So this is the value of the required starting torque for the given circuit parameters. So it's a GATE 2006 question, right? So likewise you can solve this problem. All right. So thank you very much. Thanks for watching. So do subscribe to this channel for all such kind of exam oriented questions. Thank you very much.